Hello, my dear students. Today we will be discussing potential and kinetic energy. But before we start our discussion on potential and kinetic energy, let us recall the definition of energy. So, energy is the ability to do work or cause a change. So, what does this mean? Whenever work is done, energy is transferred to that object. So, whenever work is done, energy is involved. So, what do you think the unit for energy is? So, since energy is the ability or the capacity to do work, the unit of work and the unit of energy are the same, which is joules. So, now let us proceed to the two states or general forms of energy. So there are two states or general forms of energy, namely kinetic energy and potential energy. Kinetic energy is also called the moving energy because this energy is related to objects that are moving. What forms of energy fall under kinetic energy? These are mechanical energy, light energy, sound energy, thermal energy, and electrical energy. So these forms of energy are related to moving objects. Now, what factors affect kinetic energy? So kinetic energy increases as mass and velocity increase. What does this mean? Suppose you have two objects of equal velocities but of different masses. Less mass means less kinetic energy, and greater mass means greater kinetic energy. Now, what if you have two objects of equal masses but different velocities? Greater velocity means greater kinetic energy. Less velocity means less kinetic energy. Based from these two factors, we can now derive the equation for kinetic energy. So kinetic energy is equal to 1/2 mv squared, where m is mass in kilogram or kg. V is velocity in meter per second or m over s. Combining the mass and the velocity squared, we can now have the unit kilogram meter squared per second squared. And kilogram meter squared per second squared is also known as joules with the symbol of capital letter J. Now, let us try to solve what does this mean? So greater mass means greater kinetic energy. How about the definition of velocity is squared? Would velocity have the same, less, or more effect than mass on the kinetic energy of an object? The answer is more, because velocity is squared. So what would happen if velocity is doubled? The velocity will be quadrupled or 4 times. So therefore, the kinetic energy would be quadrupled or 4 times. So that is the definition or the effect of velocity is squared in the kinetic energy equation. Now let us solve some kinetic energy problems. Determine the kinetic energy of a 625 kilogram roller coaster car that is moving with a speed of 18.3 meter per second. So using the Gressa method, the given required equation, solution, and answer, we can solve the problem. So what quantities are given in the problem? Mass, which is 625 kilogram, and velocity, which is 18.3 meter per second. The required is kinetic energy or KE. Equation, KE is equal to 1/2 mv squared. Solution, KE is equal to 1/2 mv squared. is equal to 1 half 625 kilogram times 18.3 meter per second squared. So the tentative answer is 104,653.13 kilogram meter squared per second squared. And our final answer will be kinetic energy is equivalent to 104,653.13 joules. Now, what will happen if the same roller coaster in the given problem were moving with twice the speed? What would be its kinetic energy? So the given are the mass, which is 625 kilogram, velocity, which is twice the original velocity, which is 36.6 meter per second, kinetic energy, which is required, equation, Ke is equal to 1 half mv squared. Solution, Ke is equal to 1 half mv squared is equal to 1 half 625 kilogram times 36.6 meter per second squared. So the tentative answer is 418,612.5 kilogram meter squared per second squared. And the final answer is kinetic energy is 418,612.5 joules. If you will compare the kinetic energy of problem 2 with problem 1, you will see that the value of kinetic energy was increased 4 times. Okay? Now, what if the unknown quantity is not kinetic energy? Example, if a 5 kilogram ball has a kinetic energy of 100 joules, what will be its velocity? So using the Gressa method, the given are the kinetic energy, which is equivalent to 100 joules, and mass, which is equivalent to 5 kilogram. However, the quantity that is required is velocity. So we need to derive an equation for velocity. So kinetic energy can be rewritten as Ke is equal to mv squared over 2. So to remove the 1 half in the equation, we multiply both sides by 2. So it will become 2Ke is equivalent to mv squared. Now, to remove m, we multiply both sides by 1 over m. So it will become 2Ke over m is equal to v squared. So to have a working equation, we need to get the square root of the equation. So the square root of 2Ke over m is equal to the square root of v squared. So the square root of v squared will become v. And v will be equivalent to square root of 2Ke over m. Going back to our problem, we already have the given, which are the mass of 5 kilogram and kinetic energy of 100 joules. We are looking for velocity, and we were able to identify or derive the equation, which is v is equal to the square root of 2Ke over m. Substituting our given quantities, we now have square root of 2 times 100 joules divided by 5 kilogram, resulting to the square root of 40 kilogram meter squared per second squared over kilogram. Canceling the kilogram in the numerator and the denominator and getting the square root, we will be able to arrive at a final answer of 6.32 meter per second.